Okay, question 2 asks us to compare these two graphs. We have the graph of f of x and the graph of g of x. And we need to compare them using these characteristics. So down below, we have a chart that helps us to fill in this information. And I'm going to start with the vertex and the line of symmetry. Now the vertex, that's just another name for a minimum or a maximum point. So the vertex is just another name for a minimum or maximum point. So if I'm looking at these two graphs, f of x does have a maximum point right here. That's the highest this graph goes. However, g of x, if I go down to the bottom, I don't see a lowest point. If I go up to the top, I don't see a highest point. So this one actually, g of x does not have vertex. So I'm going to put n/a, where you can put like none, no, something that tells me that g of x does not have a vertex. But f of x does have a vertex, and that is at this point. Well, this is at -1, -2, -3. So the x value is -3. And then it has a height of 0. It's on this x-axis, so it has a height of 0. So that point would be -3, 0. That is the vertex of f of x, point -3, 0. Okay. Then line of symmetry, as we said on question 1, is the line that you could draw on the graph that would cut the graph in half. That is going to be, so let me see if I can move this here because I'll use it later. But the line of symmetry is going to be right here. It goes through the middle of this graph and cuts it in half. Well, this line is at -3. The x value of this line is -3, so we would say that this line of symmetry is x equals -3. Then for g of x, if we're looking at a line of symmetry, there isn't really a line that I could put on here that would make it the same on both sides. If I draw a line like this, that doesn't work because one side of the graph is going down over here, the other side of the graph is on like the upper side, so it's not the same if I do it that way. If I were to draw a line of symmetry horizontally, it would be the same thing. We have one graph that's on the right side over here, one side that's on the left, so it's not the same on both sides when I drew a line of symmetry on there. So again, for g of x, there is no line of symmetry. This would be another n/a, which means not applicable, or you could say no or none. Something that tells me that there isn't a line of symmetry for g of x. For the x and y intercepts, those are the points where the graph touches the x and y axis. So these kind of darker lines that have the numbers on them are the x and the y axis. We already know the x-intercept for f of x. It's at this point 3, 0, which was the vertex. Sorry, -3, 0, which is the vertex. That is the x-intercept. -3, 0. So the point on f of x where we touch the y-axis is down here, and this is the point 0, -4. So that is the y-intercept for this graph, where it touches the y-axis. Then for g of x, again, the x-axis is the one that goes left to right, the y-axis is the one that goes up and down. So here is our x-intercept, which is at the point 4, 0. And then up here is our y-intercept, which is at the point 0, 12. Several people did very good at finding the numbers like -3, -4, 4, and 12. The important thing is to remember the order in which these numbers should go. The first number should tell you how far to the left or right you're going. So for this point, we go 1, 2, 3, 4 to the right, and then 0 up. That's why the 4 goes first. For the other number, the y-intercept for g of x, we don't go left and right at all, but we go 12 up. And so the first number 0 tells you go 0 left to right. The second number 12 tells you go 12 up and down. So it's important to make sure you're putting the numbers in the correct order. For the domain and range, we're looking left to right. We're seeing how far to the left does the graph go and how far to the right does the graph go. So this graph on your paper had arrows, so I just drew them in so that way we could see them. Actually, I think I want that's still there. But we are looking from left to right for the domain. This graph, if you're looking at how far to the left it goes to the left forever. It does not stop going to the left. And same thing as we're going to the right. If you see how far to the right it goes, this graph is going to the right forever. So when we have a graph that is going to the left forever and to the right forever, that is going to be all real numbers. Or we also talked about it being from negative infinity to infinity. So another way you could write this answer, same thing, would be from negative infinity to infinity. Just two different ways of writing the same number, or same answer. So let's look at g of x. G of x, if we look to the left, so I want to see how far to the left this is going, it is also going to the left forever. And if I look to the right, see how far to the right it's going, it's also going to the right forever. So this would again be all real numbers, or from negative infinity to infinity. You can put either one. For the range, we're looking at how far up and down it goes. So if we're back to looking at f of x, we do see that it goes down forever. That's why we have these arrows here at the end. It does go down forever. But it does not go up forever. We get to this highest point on f of x. This highest point has a y value of 0, and that's the y value of that point, which is the highest that graph goes. The y value tells you the height. So if 0 is the highest our graph can go, that means that y is going to be less than or equal to 0, because all of our graph is below or equal to 0. But then for g of x, this is going to be, it goes down forever. You can see it goes down forever, and it goes up forever. So this is going to be, again, all real numbers. Or we could say from negative infinity to infinity, but this time we should have y in the middle because we're looking at the range. The range is the y values. So if you're going to say negative infinity to infinity for the range, make sure you have y in the middle. Finally, for question 2, we have the intervals of increasing versus decreasing. For graph f of x, let me erase so I can redraw some things. But this graph is going to be increasing in this section right here. This is where the graph is going up. So the graph is going up from this left side of the graph, which is going all the way to negative infinity. And then it's going until we get to this point at negative 3. So we could say that it's increasing from negative infinity until we get to 3. And then on the other side is where it's decreasing. It starts at negative 3, and then it goes right forever till we get to infinity. Oops, sorry, this should be negative 3, not positive 3. So for where it's decreasing, it's going to be from negative 3 to positive infinity is where the graph is decreasing. If we look at g of x, I'm trying to see where it's increasing or decreasing. Well, for g of x, it doesn't matter where I start on the line. If I'm moving to the right, I'm always going down. So this graph is going down the whole time as we go to the right. So this graph is actually only decreasing, which means it is not increasing at all. And it is decreasing for all real numbers. It's decreasing the whole time. This is going to be from negative infinity to infinity. One thing to notice here is that for each of these, for increasing and decreasing, x is our variable that we're working with. We're looking at what's happening as we go to the right, and moving to the right is an x value. So for your increasing and decreasing intervals, you should always have x as your variable. And that is all for question 2.